Hey, it's the Pythagorean Theorem. It's time to get a cup of coffee, settle up, and enjoy the show. Now, of course, you've seen Pythagorean Theorem probably in previous math classes, so this is most likely a review. But this is kind of a famously used equation for Pythagorean Theorem, x squared plus y squared equals z squared. But we're going to upgrade to a better one that's more informative. Replace this with this. Side squared plus side squared equals hypotenuse squared. Now what is this thing doing for us? This thing is helping us find missing sides of a right triangle. So we'll use Pythagorean theorem when we have a right triangle, a triangle with a 90-degree angle. And when I say side, side, and hypotenuse, there's two sides. These are the sides that form the right angle. So that's what we'll call the side. And the hypotenuse is always the side that is opposite the right angle. So they all seem like sides, but this is a special side, it's the hypotenuse. Well, let's look at about 2 or 3 examples of this in action and you're good to go. In this first example, I have a right triangle. Remember that the Pythagorean theorem will not work if you don't have a right triangle, a triangle with a 90-degree angle. And I'm missing a side. I have a hypotenuse, but these two sides form the right angle, so these are the two sides. I'm missing that side, so I now employ the Pythagorean theorem. Here we go. First recommended step, always begin by writing out the Pythagorean theorem. Next recommended step, right below each piece, fill in information from the triangle. We're missing a side. I'll use a question mark. You can use an X if you'd like. Hypotenuse, side. Now I just turned 12 squared into a number, 13 squared into another number, and my goal, by the way, is to solve for this question mark. And remember, you can call it X if you don't like it being a question mark. I moved to the 144 to the other side. It was plus 144, so I subtracted. So now I have question mark squared equals 25. And how do you kill a squared in an equation? You square root it. So what I end up with is question mark equals, and remember when you square root in an equation, you need the plus or the minus, but in this case, this is a distance, and a distance can't be negative, so my final answer is the distance is positive 5. We now know the length of that side is 5, and this triangle, by the way, as you go into geometry, will become a famous triangle called the 5, 12, 13 Pythagorean triple, but that's for next year. Here's another example, and I'm going to put down my work and then I'll comment about it, but before we do that, realize that I have a right triangle. I'm missing a hypotenuse. Now I can find that using the Pythagorean theorem. Here's my work. I always start out by writing the Pythagorean theorem, then I fill in information from the triangle. Since I was missing a hypotenuse, I decided I'd go ahead and use h for my variable. Could use a question mark, could use an x, a y, whatever you want. And now I just solve for h. And by the way, h is already by itself, basically. I eventually have to square root to get rid of the squared. But I didn't have to do as much algebra, as many algebra steps as I had to in the previous problem. So you should be able to look line to line and see what the heck was going on. We're just doing all the steps that we normally do to solve an equation. So far the first 2 problems have both ended with integer answers, which is nice because people love integers, but sometimes it can be a decimal, and then as you find out tomorrow, sometimes we're going to end up working with radicals and have radicals in this Pythagorean theorem. This final example is going to show you a plausible reason on why you would use a Pythagorean theorem, and also going to show you that we don't always have to have integers. So let's pretend you're working on a construction project, and for some reason you've got an 8-foot piece of equipment, and it's got to get through this doorway. And it's 8 feet tall, so you know it doesn't fit upright through the 7-foot doorway. You couldn't turn it totally sideways because that's only 3.5 feet wide. So you say to yourself, well, I could kind of put it diagonally through here and I could fit it through. but you don't have a tape measure or some measuring device that you trust to be able to stretch perfectly on a straight line along that diagonal. So you don't quite know for sure if this thing is going to fit through there. And now, of course, for this example to be realistic, there has to be a good reason why you can't just do this by trial and error. So you're deciding that you're going to figure out that distance to see if it's big enough to allow that to go through. So I've redrawn the situation, and I put the diagonal going the other way instead of this way, but it really doesn't matter because they're going to be the same distance. And the reason I redrew this situation is now we're going to envision that we've got ourselves a triangle, a right triangle, because if things are going well, that's a right angle, or we haven't built this doorway very well. And I have to envision that right triangle. Well, as soon as I envision that right triangle, I know I can find that missing piece because it's the hypotenuse. So I can just go ahead and build this triangle, or use this triangle to build the Pythagorean theorem. And as I go through here, I end up with h equals 7.83. I end up with a distance of 7.83, which tells me that 8-foot board, or whatever equipment I have, there's no way it's going to fit through that doorway because this would have been the best chance, not big enough. Now in this case, we ended up with a decimal, and that's totally fine. In fact, almost all the time you should end up with a decimal in a real applied situation. And the next time we work on the Pythagorean theorem, we're going to see what happens when you end up with radicals inside there. That's the Pythagorean theorem. I highly, highly suggest that you always start off with these two steps. Write out the Pythagorean theorem in words or symbols. Then the very next step, replace with any values that you have. You're going to have a variable or a missing value. Use your algebra skills to solve for that.